Okay, we're going to complete the rational functions unit with the applications. And this front page that you'll see in the document that's uploaded is a set of formulas for you to use. We're going to focus on these first 4 formulas. This last one I've taken off and you don't have to worry about it. But we have the ratio problem where we set up a proportion. We have this jobs problem, which is huge on the ACT. You see it all the time, every ACT you take. You have distance equals rate times time, which if you divide and get rate by itself, divide both sides by t, you get distance divided by time, and solve for time, divide both sides by r, you get time is distance over rate. So if something's going the same rate, 2 things are going the same rate, you use this. If 2 things are going the same time, you use that, and you'll form a ratio or a proportion. And also current and wind. This has to do with flying and water problems, upstream, upwind, that kind of thing. That you take your still and you subtract if you're going up or into, and you take the still and add if you're going downstream or with. It pushes you and makes you go faster, or it pulls you and makes you go slower. And we're not doing the alloys problem. Now this document's really long, but I want you to refer to this as we go through everything. I would print this out. I don't ask you really to print a whole lot out, that you can do a lot on your own sheets of paper, but I would print this out to be able to follow it, which is on the next sheet, the problems we're going to do for notes. Now this week, my focus is for you to understand these problems. You're not doing a whole lot of different worksheets, just these problems and understanding them and watching this video probably a few times to understand it. The first problem for notes we have is a ratio problem. To set up that ratio, you need to really look at the wording. It changes a lot. We have the ratio of 8 less than a number. I don't know what that number is. We're going to call it x, but 8 less than it. The ratio 2 means that's where your fraction is. 28 more than the number. Remember, the number is x. 28 more than it, x plus 28. Is your equal sign, 2 to 5. So if we're looking back at these formulas, is your equal sign right here? The word 2 is that fraction bar. Try and straighten this back out. That gives me a ratio to set up of what they've given us. Remember, the number we don't know, we're going to call x. We want 8 less than it. We want 24 more than it. We have your is your equal sign, and the words 2 are the fractions. So piecing that together gives me the equation x minus 8 to x plus 28 is, that's equals 2 to 5. If you remember, in middle school, you can cross multiply. 5 times x minus 8 is 5x minus 40 equals 2 times x plus 28, 2x plus 56. And if you solve to get x by itself, you get 32. One of the keys to these problems is that looking at the question itself, what is the number? The number is x. That'll be my solution. That's what I found. But it asks you different questions. You need to really be careful with what they're asking you for those problems. On number 2, we're talking about a jobs problem. Andrew can complete a plumbing job in 6 hours. Matt can do the same job in 4 hours. How long will it take them to do the job working together? We don't know the working together. Working together is going to be our x. But if you go back up to the top, look at, there it is, the jobs, we do 1 over a part, Andrew's part here, times together, which we don't know is x, plus 1 over part, 1 over Matthew's part, times together, we don't know, x is equal to 1. We'll set that up for the second problem. I don't know how much it takes working together, but I do know that Andrew can do his part is 6 and Matt can do his part in 4, and it's all equal to 1 job. My together is x. That makes Andrew 1/6 times x. That's a times sign. Plus Matt is a 1/4, because 4 hours for his part, times x equals one job, is just always equal to that one job. You simplify each of these fractions. Remember that this is a fraction of x over 1, and that's an x over 1. You multiply them together, you get x over 6 plus x over 4 equals 1. And an easy way to get rid of all of these fractions is to multiply by the common denominator, which you could make it 12 or you could make it 24. Doesn't matter which one you do. If you do 12, it'll be multiplying everything by 12 over 1, and that's, I'll show you, it's going to clear out these fractions, because 6 goes into 12 2 times, and that gives me 2 times x, which is 2x. 4 goes into 12 3 times, which is 3 times x, 3x, equals 12 times 1, 12. Solve this equation, 5x is 12. Divide by 5, and we get 2.4 hours. That's how long it takes them to work together, and that's what the question asked. How long does it take them to work together? Number 3 is also a jobs problem. 2 pipes can fill in 8.4 hours. That's their together time. 2 of them together, 8.4. The smaller pipe part is 28 hours. The larger pipe, we don't know, is going to be x. My equation, filling in that formula, again, you should have a look at that formula if you're confused. The smaller pipe's part, 1 over 28, times the together that we know this time, 8.4, plus the larger pipe part, we don't know, 1 over x, times the together, 8.4, gives you one job, equals one job. Just like up in number 2, you multiply these fractions, you get 8.4 over 28 plus 8.4 over x equals 1. And an easy way to clear out the denominators is to multiply by the common denominator, which is 28 times x. I'm going to multiply everything by 28x over 1. (28) and 28 cancel. I get 8.4 times x. And then the x's cancel, and I get 8.4 times 28, which is, I don't have it written down. I'll calculate that. Equals 28x. Okay, that's 235.2. And when you subtract the x over, we're solving for x, we get 235.2 equals 19.6x, and divide, and we get 12. X is 12. That's how much, 12 hours, it takes the larger pipe to do the job alone. That's what the question was. Now we're going to talk about distance and rate. First, on number 4, the speed of train A is 12 kilometers slower than the speed of train B. Train A travels 230 kilometers in the same time. That is our key, same time it takes train B to travel 290 kilometers. That means that for train A, train A's time is going to be the distance it takes train A divided by the rate at train A. And train B's time is going to be the distance for train B divided by the rate of train B. And those two, that fraction and that fraction, are equal to each other. The distance for train A is 230. The rate of train A is 12 kilometers slower than B. 12 kilometers slower than B. The distance for train B, equal to this, is 290, and the rate of train B is just x. If you cross multiply these, we get, remember that it's a proportion, so we cross multiply, we get 230x is equal to 290x minus 3480. And if you solve for x, we get that x is 58 kilometers per hour. That is the rate, if you look at what we've solved, kilometers per hour for train B. It says find the speed of each train, so 12 kilometers less is 46 kilometers per hour for train A. That's the same time problem if you look at the formulas up above. Now the same thing here on number 5, it says same time again. So we have similar formulas as what you saw right here, except we're talking now about an upstream and a downstream. Notice that the boat can't go as far upstream because the rate's going to be slower, and it can go further downstream because that rate is going to be higher. It's going to be going faster downstream as it gets pushed. It's going to be slower upstream as it gets pulled. So our distance and our rate, look up in your formulas, up on those that I told you to print out. We're going to solve this equation. Same time means distance over rate equals distance over rate. The distance upstream is 50. We don't know the speed of the current. Find the speed of the current. The still water is 15. We don't know what the current is. So that means that still is 15 minus the current, and the distance downstream is 70, and the still is 15, and we don't know the current, and we add it. We go through, we cross multiply, just like we've done in a few of these problems, and we get, let's see if I have those calculations. I do. We get 750 plus 50x is equal to 1050 minus 70x. And if you go through and solve, you get x is 2.5. Remember, x is actually the current of the river, so it's miles per hour. Oh, and that's our last one for notes. So I would pause, try these again, look at the setups so that you can see how to do your problems. There's only 7 problems to do. You have a little bit of everything, a couple of these proportion, ratio problems. You have a couple of jobs problems to do, set up a couple of jobs problems like these two, and you have some distance and rate problems to put together. I want to see those worked out completely. Show me the equations you give me. Show me all this work and make sure you fully answer those questions.